Salicylate, a very common drug used in everyday use. It is a non-steroidal anti-inflammatory drug. It's an analgesic and aspirin, etc. You people know that is very frequently taken. But overdose can lead to poisoning and certain acid-based problems we are going to talk today. Now, the simple explanation, it causes alkalosis actually. Alkalosis. Normally, the pH is 7.4 plus minus 0.5. If it crosses the upper limit, it is alkalosis. So, salicylates, overdose, they are actually stimulator of the respiratory system. तो respiration अगर stimulate हो गया, fast breathing, then that washes off carbon dioxide. So carbon dioxide washed out, carbon dioxide pressure in the blood decreases, and as you all know, carbon dioxide is an acidic product of metabolism. तो CO2 कम हो गया, acid wash out हो गया, the result will be alkalosis. That is the simple explanation we can provide, and that is correct also, except one thing, that it is oversimplification. Let us elaborate it a bit with the help of Henderson-Hasselbalch equation. This is pH is equal to pK plus log of base by acid concentration. The base is bicarbonate and the acid is H2CO3. Now you people all know, as we said just now, 7.4 plus minus 0.5. pK is an immutable constant. It is negative logarithm of dissociation constant of H2CO3. So whatever, it is a constant value. So how the pH can change? The pH can change only when this ratio of base by acid changes. So normally this ratio is 20. The reason being that HCO3 concentration is 25 millimole per liter and H2CO3 ka 1.2. So the ratio becomes 20. So in salicylate poisoning, overdose, toxicity, what we said that CO2 is washed out and carbon dioxide, all of you know very well that carbon dioxide combines with water to give rise to H2CO3. The enzyme is carbonic anhydrase. The enzyme having largest turnover number. So this reaction is very much possible in our body, although not in outside our body. So enzyme catalyze H2CO3. अब अगर आप ये देखें, CO2 washed out means partial pressure of CO2 has fallen down. The result will be H2CO3 concentration will also fall down. So इस denominator को अगर decrease हो गया, if the concentration of denominator is decreased, then the result will be the ratio will increase. Let me clarify, अगर ये 1.2 से 1.0 हो गया, I am repeating it because CO2 being washed out, CO2 dissolved carbon dioxide is in equilibrium with H2CO3, so H2CO3 has fallen down from 1.2 to 1.0. So the ratio also has increased now to 25. Okay. Now we discussed in the very beginning that only way pH can change is change in the ratio. And when the denominator decreases, the ratio increases. So increase in the ratio will result in increase in the pH. And that is what is called alkalosis. Now, alkalosis, that's all right. But what type of alkalosis is it? Is it respiratory or is it metabolic? You see, the primary defect is in the respiration, enhanced breathing. So it is a case of respiratory alkalosis. We will discuss in a subsequent lecture how this is compensated for. So one or two very simple questions for you, but before that, let me summarize very quickly. Number one, respiratory stimulation. Number two, PCO2, partial pressure of CO2 falls down. Consequently, H2CO3, the denominator concentration falls down. Number four, the ratio increases and the pH also increases. Now, one or two questions. A question, it is a fallacious question. Please catch the fallacy. In diabetic ketoacidosis also, kusumul breathing, the patient breathes deeply, fast, something like salicylate toxicity. But there, the defect is diabetic ketoacidosis, acidosis. So enhanced respiration is causing acidosis there, it appears, and alkalosis here. Why? And secondly, prolonged toxicity of salicylates also can also lead to acidosis. So this we will discuss in a subsequent class. So that's all for today.